Hello, and today we're going through coordinate geometry. So let's get started. Let's start with the midpoint. So the midpoint of a 2 points on a graph. So say x1, y1, and x2, y2. The midpoint between this is just x1 plus x2 over 2, and y1 plus y2 over 2. And this is the midpoint. To find the length between the 2 points, we can do square root of change in x squared plus change in y squared is equal to the length, and change in x can be x2 minus x1, which is equal to delta x, and change in y is x2 minus y2 minus y1, which is equal to delta y. Now finding the gradient of a line, you can just do delta y over delta x, and also tan theta is equal to the gradient m if you have a line like this with a angle to the horizontal theta. Now if you have a gradient of a perpendicular line, so you have a line like this which has a gradient m1, and you have a line like this m2, and it's perpendicular as we've shown here, the gradient of m1 is going to be equal to 1 minus 1 over m2, and the same will be the other way around, so m2 is equal to minus 1 over m1. This is the negative reciprocal. And let's go on to the equation of a straight line. So the equation of a straight line is y equals mx plus c, and you can represent it in different forms. Say let's draw graphs like this: y, x, and you have for example x equals a as an equation of a line. You can also have y equals a, for example. That's another equation of a line, and the rest and then you can get, when it's through the origin, going through the origin, you can get y is equal to mx, because you have the y-intercept is 0 because it goes through the origin, which is 0, 0. And then you can get lines in the form, like the equation of a line, you can get in the form ax plus by plus c equals 0. It's just rearranging the y equals mx plus c into a different form. There's different values of c as well. So to find the equation of a line using two coordinates, so say we have two coordinates, x1, y1, and x2, y2, then the gradient will be, again, change in y over change in x, which is equal to minus y2 minus y1 over x2 minus x1. And then now you can substitute the value of m into y equals mx plus c, a general formula like this, and you know what the value of m is. And then just substitute either y1 is equal to m x1 plus c to find what c is, or you can do y2 is equal to m x2 plus c to find what c is. And that's it. And then you can find out the equation, the total equation, and leave it in terms of y equals mx plus c, but where this is known and this is known. Cool. Now, if you have an intersection between two lines, so you have two lines, y equals mx plus c, m1x plus c, and y is equal to m2x plus c 2, there should be 2 points x, y. There should be a point where x, y, which satisfies both of these equations. So let's do an example. So for example, if you have a line joining 2, 5, and 6, 3, how would we find the equation of the line, the length of the line, the midpoint, and the perpendicular distance? So if we find the equation first, so we're looking for the equation. So we would do find m first, which is, so 3 minus 5 over 6 minus 2, and we get minus a half. And then we substitute into y is equal to minus a half x plus c. And we can use any of these two to substitute into this equation as a y and x to find c. So we can do 3 and 6. So y equals 3 is equal to minus a half 6 plus c. And then we rearrange to find c, and we find that c is equal to 6. So the final equation will be y is equal to minus a half x plus 6. That's the equation of the line. And now if we want to find the length of these 2 points, so what we do is from before, square root, changing y squared plus changing x squared. So changing y squared was again 3 minus 5 squared, and changing x was 6 minus 2 squared, and we will get root 20. So that's the length, so that's part 2, and this is part 1. Now let's go find the midpoint. So to find a midpoint, we'll just do 2 plus 6 over 2 for the x, and for the y, we can have 5 plus 3, which is the y values, 5 plus 3 over 2. And this is equal to 8 over 2 and 8 over 2, which is equal to 4. And that's the midpoint. And finally, let's find the perpendicular gradient of this graph. So we said the gradient was minus a half, so minus a half is equal to m1. So minus 1 over minus a half is equal to m2, which is the negative reciprocal, which is equal to just 2. And that's it. Let's go on to the equation of a circle. So equation of a circle. Of a circle. And for the equation of a circle, we would have x minus a squared plus y minus b squared is equal to r squared. So this is the format we would have it in, where AB is the center of the circle, and r is the radius of the circle. And let's try some examples of like where we would use this. So say we have a circle like here on the coordinate axis. Let me write it down, x and y. And we have a circle that goes somewhere like this. Okay, and make sure, so there's an intersection there, but this is a bit badly drawn. And the circle intersects at 2 on the x, 8 on the x, and on the y, it is at 4. So let's find the equation of the circle. So how would we do this? Using what we've learned, everything that we've learned, we know that the center of the circle, because it's in the middle here, this is the center, we would know that it would lie in between, halfway in between this point and this point. Let's find the x coordinate. So we can do, if it's halfway in between, we'll do the value of the midpoint, which is equal to 10 over 2, which is equal to 5, which is equal to the x value of the midpoint. So we can just call this a. And for the y value, we can see that it just touches at this point, which means that we can say safely that the center has to be on the same y value as 4. So we can say b is equal to 4. So now we have the equation minus a, which is 5, squared plus y minus 4 squared is equal to r squared. So how would we find the radius? We know that the center already is 5, 4. And this point on the edge is just 0. So the x value is 0 and the y value is 4. So the distance from here to here must be 5. So we know that this is the radius, so the radius must be equal to 5. So r is equal to 5. And let's substitute in this equation, x minus 5 squared plus y minus 4 squared is equal to 5 squared, which is 25. And this is the equation of the circle. Cool. Now let's go on to some circle rules. So we'll do 3 circle rules. So the first one can be, so if you have a circle, this, and you have a triangle in that circle, the angle in this, and this goes through the center of the circle. So this is a semicircle is this part over here. So the angle, this angle here is always going to be a right angle if this goes through the center of the circle. That's first rule. Second rule, we can say that the radius, so if we draw another circle, we can say that the radius, so say we have the center again, and we have radius like this, we can say that the radius is perpendicular to the chord and it bisects it. So it bisects the chord, saying that this side is the same as this side in length. And the third one is, let's draw another circle. If we have a tangent to the circle, yeah, okay, like a tangent like this, the radius will always be perpendicular to the tangent. So these are 3 rules, circle rules. We'll try some questions. Say we have a circle, so on a coordinate axis like this and this, and we have a circle at the origin like this. That's a horrible circle, but you can understand. It doesn't need to be perfect. X squared plus y squared is equal to 25 is the equation of the circle. And find the equation of a tangent, which is at a point 4, 3, right there. So that's this point here. Find the equation of the tangent of the circle that lies at 4, 3. So how would we do this? We know from the circle rules that a tangent must be perpendicular to the radius. So let's find the radius first. We can tell that the radius, if we draw a line of the radius, we can get radius like this, and we would know that this is perpendicular, right? So we have 2 points. We have 0, 0, because we know it's the origin, because there's no a and b are 0 in the equation of the circle. And we know the other point is 4, 3. So we have 2 points, 0, 0, 0, and 4, 3. And how would we find the tangent to the circle? So how would we find the gradient of the radius first of all? So what we'd do is just change in y, which is 3 minus 0 over 4 minus 0. which is equal to 3 over 4. And remember, because it's perpendicular, we have to do the negative reciprocal. So 1 over minus 1 over 3 over 4, which is equal to minus 4 over 3, would be the gradient of the tangent. And because the tangent is a straight line, we can just write it in terms of y equals mx plus c. And now let's substitute everything into the equation. Because we know what y is equal to minus 4 over 3 x plus c, and we have 1 point, the 4 over 3 that goes through that line, we can substitute. So we have 4 over 3, 4, 3, so y equals 3, minus 4 over 3, x equals 4, and c. Now we solve for c, and we get b equals minus 16 over 3 plus c. And we'll add 16 over 3 on both sides. C is equal to 25 over 3. And remember, we can write this out, minus 4 over 3, x plus 25 over 3. And we have a version of the equation, but what we can do is leave it in this form that we said before. So we can leave it in terms of 3y is equal to minus 4x plus 25. And we can leave everything on one side and make it equal to 0. So we have 4x plus 3y minus 25 is equal to 0. We can leave it in this form here. Now let's try one more question. So say we have a circle of our equation, this squared is equal to 9. And we have an equation of y is equal to x squared minus 3. So this is a circle, and this is a curve. And let's find the points of intersection. So we would use simultaneous equations, right? So we know already the value of y, so we can do this equation of a circle. And because we know what y is, we can just substitute the value of y inside, and we'll get is equal to 9. Now this, we can expand this out like this, minus 3 squared minus 3. And remember, x4 minus 3x squared minus 3x squared plus 9. And we'll get a quartic with this, minus 6x squared plus 9. And if we substitute that back into the equation, we're going to get x to the power 4 minus 5x squared plus 9 is equal to 9. And we can take away 9 on both sides. So we're going to get x to the power 4 minus 5x squared, which is equal to 0. And we can take out x squared, and x squared minus 5 is equal to 0. So we have two values for x. X could be either 0, because x squared is equal to 0, so x must be equal to 0. And x squared minus 5 is equal to 0, so x could be equal to plus minus root 5 as our values for x. And if we find the y values, so y is equal to x squared minus 3. So if x equals 0, y is going to be equal to minus 3. So you have a y value. And if x equals x squared minus 3, if x is equal to either plus minus root 5, we're going to get y is equal to 5 minus 3, which is equal to 2. So now we have three coordinates, either 0, minus 3, plus 5, root 5, 2, or minus root 5, 2. And these are all our coordinates of intersection. And that's pretty much it for coordinate geometry. Thank you for watching.